let's start with the salt analysis. If you see any salt, it has two ions. For example, this is NaCl, sodium chloride. It has two ions. Number one is positive ion and the second one is negative ion. Both the ions, they are identified in the separate test. And very first thing we'll perform test of cation, and the second thing we'll perform test for anions. And by combining those two results, by test of cation and test of anion, we will be able to tell this is a name of a salt. So there is a series of cations. They are the part of our syllabus. Now let's start how we can identify cation. For example, there is two chemicals they are used to identify cation, and this is a list of cations that are the part of your syllabus. Number one is calcium, Ca2 positive ion, and second is aluminum 3 positive, and third is zinc 2 positive. And next one, they are for transition metals. They are iron 2 positive, and iron 3 positive, chromium 2 positive, no, sorry, chromium 3 positive, and second last one is copper 2 positive, and the last thing is going to be ammonium ion. These are the cations that are part of our syllabus. Now, these are the two chemicals which are used to identify cation. Very first thing is sodium hydroxide. This is NaOH, few drops. First of all, we'll add few drops of NaOH, then excess NaOH. In the same test tube, we'll add excess NaOH and we'll note the observation. And second is NH3 aqueous. This is will perform in a second test tube. We'll add NH3 aqueous in the second or in a separate test tube, and in the same test tube we will add excess NH3 and we will note the observation. The very first thing, if we'll add NaOH, few drops into calcium, aluminum and zinc, they form white PPT. These are the precipitate of hydroxide. Now calcium reacts with OH negative ion to form calcium hydroxide. And again, aluminum 3 positive, again it forms white precipitate. And again, that precipitate is for aluminum hydroxide, AlOH3, and zinc also form white PPT, and that is for zinc hydroxide. These are the precipitate they are formed when you add few drops of NH3 aqueous. Now, these are the non-transition metals. They are not a transition metal, so this is the reason they are forming white PPT. But if you see for transition metals, iron 2 positive, iron 3, and chromium and copper, they form colored precipitate. If you see this thing, iron 2 forms green precipitate. These are the color change. Iron 2 forms green precipitate of iron hydroxide, and iron 3, it forms red-brown. It forms red-brown precipitate, and that is for iron 3 hydroxide, that is FeOH whole thrice. And for chromium, chromium also forms green precipitate. Iron 2 and chromium 3, they form same color precipitate, that is green. Chromium 3 forms CrOH whole thrice. These are the color of these transition metals. But copper forms blue precipitate. Blue precipitate of OA, copper OH whole twice. These are the precipitate of copper hydroxide. Now you can see calcium, aluminum and zinc, they are not transition metals. So if they are not transition metal, they will form white PPT. Transition metals, they form white precipitate. In a similar way, they are colored solution. Transition metal, they form colored solution. If you are going to dissolve into a water, if a salt you are going to dissolve into a water, it form a colorless solution. It means transition metal is not present. And if it is forming a colored solution, it means their transition metal is present. And for ammonium ion, you need to heat up when you add few drops of sodium hydroxide. Heat up or warm it, slightly warm, or heat up. When you warm it or slightly warm, it releases ammonia gas. It releases ammonia gas, which turns damp red litmus paper into blue. This is a positive test for ammonia gas. damp red litmus paper into blue. You don't need to add excess sodium hydroxide into ammonium ion. Now, what will happen when you add excess NaOH in the same test tube, calcium hydroxide? First, you added few drops of sodium hydroxide, you are getting white PPT. And in the case of sodium hydroxide, PPT does not dissolve. PPT remain insoluble. So this is PPT insoluble. And no, there are three white PPT. Number one was calcium, second aluminum, third is zinc. Out of these three precipitate of calcium does not dissolve, but precipitate of aluminum and zinc, they will dissolve. So here this is a case of aluminum and zinc. Precipitate of both the things, they will dissolve. Aluminum and zinc, their PPT dissolve. But colored precipitate, all colored precipitate, they are insoluble. For this is PPT, green PPT, they will be insoluble. And red brown PPT of iron 3 positive, they will be insoluble. And chromium, but chromium, in the case of chromium, PPT dissolve into excess sodium hydroxide. And in the case of copper, PPT does not dissolve, PPT remain insoluble. So this is a color change or PPT dissolve when you are going to add excess NaOH. Again, I repeat, for white PPT gives calcium, aluminum and zinc. Out of these three precipitate of calcium, they will remain insoluble. Aluminum and zinc, they will get dissolved. And iron 2 forms green precipitate, and all the colored precipitate, they will be insoluble except one, that is chromium 3 positive, green PPT. If by adding sodium hydroxide, if you are getting green precipitate, it means iron 2 or chromium 3 positive, they are present. By adding excess NaOH, if PPT get dissolved, it means there is chromium 3 positive ion is present. If PPT does not dissolve, it means there is going to be iron 2 positive. And if blue PPT, that is going to be insoluble in excess. So it means it is going to be copper 2 positive. Now, color change, all these cation that is same in aqueous sodium, in aqueous ammonia, but calcium 2 positive does not give any color change. Calcium does not show any color. Sorry. Calcium, there is no change. Calcium does not react if you add NH3 aqueous. There will be no visible change. It will remain transparent. There is no change. Aluminum and zinc, they will give white PPT, and precipitate of zinc, they will get dissolved. But precipitate of aluminum hydroxide, they will not be dissolved. And for aluminum 3 positive, aluminum hydroxide PPT, they will remain insoluble. There is no precipitate, they will not be dissolved. And in a similar way, for iron 2, iron 3, they will give same precipitate, but precipitate of transition metal, all transition metal, they will remain insoluble except copper. So for this is going to be now precipitate of green, iron 2 hydroxide, this is PPT, precipitate insoluble. And same case with iron 3 positive and chromium 3 positive. Their precipitate will remain insoluble. But for blue PPT, copper hydroxide precipitate dissolve to form deep blue solution. And ammonium ion, it cannot be tested by aqueous ammonia. So this was about color change that will occur when we are going to test cation. Again, I repeat, for these tests for cation, there is 5 to 6 cation there for part of your syllabus: calcium, aluminum and zinc. They will form colorless solution. When you add excess sodium hydroxide, it forms white PPT. When you add excess sodium hydroxide, all white PPT, they will get dissolved except calcium. And in the case how we can further test for aluminum and zinc 2 positive, we can further test by adding aqueous sodium hydroxide, first few drops, then excess. In first few drops, again, aluminum and zinc, they will give white PPT, but precipitate of aluminum hydroxide will get dissolved, but precipitate of zinc 2 positive, that will get dissolved, but precipitate of aluminum, that will remain insoluble. So here the thing, we can differentiate between aluminum and zinc. If you add excess aqueous ammonia, if ppt dissolve, it means zinc. If ppt does not dissolve, it is aluminum 3 positive. But for the transition metals, we can differentiate easily. For iron 2, iron 3, same color and no ppt dissolve. A chromium 3 precipitate, and in aqueous excess ammonia, ppt does not dissolve, but there is only one transition metal that get dissolved in aqueous ammonia, that is for copper. Blue ppt, they will dissolve to form deep blue solution. So this was about test for cation. Now you can see these are the different salts, aluminum, zinc, and calcium. Here you can see there is transparent solution. There is not a colored solution. If you are getting a transparent solution, for transparent solution, it shows it is going to be a non-transition metal. Transition metal is not present in this case. And if you add sodium hydroxide, few drops, white precipitate in all these three ions you can see. But excess sodium hydroxide, precipitate of aluminum and zinc, they dissolve, but precipitate of calcium does not dissolve. In an H3 aqueous, again you are seeing this white ppt insoluble. This is positive test for aluminum 3 positive. If precipitate dissolve, it shows this is going to be a zinc 2 positive, and calcium 2 positive does not react with an NH3 aqueous. Now these are the transition metal cation. Very first thing, you should observe they all forming colored solution. Here you can see this is light blue solution, and iron 2, it's green, red, brown, a green and red brown solution. This is a blue solution. Iron 2, it's forming light green because it's very diluted, so it's light blue. And or you can say this is slightly colorless, but because it's very diluted, so it should be, if it is concentrated, it should be green solution. Now this is going to be red brown solution. Now if you add few drops of NH3 aqueous, light blue, if light blue ppt forms, it indicates this is copper hydroxide. This is copper hydroxide. Iron 2, it forms iron hydroxide. Now color change, you can see this is for green. And iron 3, it forms red brown ppt, that is for iron hydroxide, FeOH whole 3. And all these three precipitate, they all are insoluble in excess. If you add excess NaOH precipitate, they will remain insoluble. If you are getting green precipitate, for this green precipitate, we can assume either it's chromium 3 positive or iron 2 positive. If these green precipitate, they will remain insoluble, that is going to be iron 2 positive. If this ppt dissolve, in this case, if ppt dissolve, it confirms there is Cr3 positive, because precipitate of iron 2 and iron 3 positive, they are insoluble in both the solutions, in sodium hydroxide and aqueous ammonia. So these are the positive observation for cation. Now on standing in air, this is a case for iron 2 positive, iron hydroxide. If you stand on air for a few minutes, this iron 2 will turn into iron 3 positive, because iron 2 will get oxidized into iron 3 positive by atmospheric oxygen. So this thing you should keep in mind. Upon contact of iron 2 positive with air, iron 2 will get oxidized into iron 3 positive. Let's start with the test for A9. Multiple A9s are the part of your syllabus. Almost 5 to 6 A9s are the part of your syllabus. This is a list of A9s. They're the part of our syllabus: nitrate, carbonate, then halazine, chloride, bromide, and iodide. And the second last is sulfate and sulfite. Now, very first thing, test. Formula you should keep in mind. What's the formula for nitrate? That is NO3. Carbonate CO3, that is, it has valency 2 negative. All halides, they have negative 1 valency. Sulfate and sulfide, they have 2 negative valency. So how we can test these Ka anions? Number one, for nitrate, for every anion there is a different test. Unlike that is for cation. Cation, there is only two chemicals they were used, like there was sodium hydroxide and aqueous ammonia. But in anions, there are a series of tests you need to perform to test for anions. Very first thing, for nitrate. For nitrate, add sodium hydroxide, add few drops of sodium hydroxide, few drops of NaOH, followed by aluminum foil. After that, you will add aluminum powder or aluminum foil and heat up. If you heat up and if nitrate ion is present, nitrate ion will turn into ammonia. And test for or observation, what you will observe when you heat up after adding sodium hydroxide and aluminum foil, or you can write aluminum powder as well, a piece of aluminum you can write. And observation is going to be NH3 gas is released. Here you can write observation, a gas released which turns damp red litmus paper into blue. Damp red litmus paper into blue. This is a color change. If nitrate ion is there, by adding sodium hydroxide and aluminum foil, and you have to heat up, it releases a gas which turns damp red litmus paper into blue. Actually, this is a gas of ammonia. Nitrate will turn into ammonia by heating sodium hydroxide and aluminum foil. Second anion, that is for carbonate. You have learned this thing in acid, base, and salt. If you add any acid into carbonate, it releases carbon dioxide. Metal carbonate reacts with acid to form salt, water, and carbon dioxide. And for this, we will write any acid. For example, add HCl. If you add HCl into carbonate ion, this is the equation. This is HCl, or H positive ion reacts with carbonate CO3 2 negative to form water, and carbon dioxide CO2 gas will be given off. And test for this carbon dioxide, it turns lime water milky, a gas released which turns lime water milky, which turns lime water milky. Actually, lime water is calcium hydroxide. When it reacts with carbon dioxide, this is the equation. This is a lime water, calcium hydroxide. When carbon dioxide is passed, carbon dioxide is acidic gas, and calcium hydroxide, it's an alkali. Both react to form calcium carbonate, CaCO3 solid. These are white or milky precipitate. So this colorless solution will turn into white precipitate. Calcium hydroxide, it's a colorless solution. This is a positive test for carbonate. And next, for chloride, bromide, and iodide, there is same thing. You will add dilute HNO3. This dilute HNO3 is added to remove any impurity in the form of carbonate. This is a dilute HNO3 for all chloride, bromide, and iodide. When you add, after this, after adding HNO3, add silver nitrate. AgNO3 aqueous. AgNO3, it's a transparent solution. First of all, add dilute HNO3 followed by silver nitrate. And same test for bromide and iodide. This is bromide, and here this is for iodide. Now, if chloride ion is there, it is going to form white PPT forms, white PPT of AgCl. And if bromide ion is there, bromide gives off-white or creamy precipitate. Off-white, or you can write creamy precipitate form. And in the case of iodide, it gives yellow precipitate. This is a color change you will see for the test for halide ion. And this is the equation for halide ion. For Ag positive reacts with chloride to form AgCl solid. This is going to be AgCl solid, and in the case of bromide, it will form AgBr. Ag positive and Br negative, they will form AgBr solid. and AgI solid, it gives yellow precipitate. And for sulfate ion, again add dilute HNO3. After adding dilute HNO3, add barium nitrate. Barium nitrate or barium chloride, both the things you can add. Barium nitrate aqueous or barium chloride. So this is barium chloride, it's a colorless solution. In the case of sulfate, if sulfate ion is present, it forms white PPT of barium sulfate form. This is barium 2 positive and sulfate SO4 2 negative. You have learned barium sulfate, it's water insoluble. Barium sulfate, white PPT of barium sulfate will be formed. And how we can test for sulfide? There is a very simple test, add KMnO4, because this sulfide ion can get oxidized into sulfate. So add any oxidizing agent, most commonly add acidified KMnO4. KMnO4, its purple color. Its purple color will turn into colorless when you add few drops of KMnO4 into sulfide. So this is a positive test for sulfate and sulfide. Now again I repeat, for nitrate. For nitrate, add dilute sodium hydroxide followed by aluminum and heat up, and a gas is released which turns temporary litmus paper into blue. Actually, this is a conversion of NO3 1 negative into nitrate and ammonia and carbonate. Add dilute HCl, a gas will be given off which turns damp red litmus paper, which turns lime water milky. And for chloride, add dilute HNO3 followed by silver nitrate, it forms white PPT. In the case of bromide, gives off-white. And last one for iodide, it gives yellow PPT. And for sulfate and sulfide, for sulfate, add barium nitrate, acidified. Barium nitrate, it gives white precipitate of barium sulfate. And for sulfide, add acidified KMnO4, it gives purple to colorless. This is a color change. Now see this test for halide ion observation. This is a silver nitrate which is a colorless solution. AgNO3, this is a colorless solution. Very first thing, and the silver nitrate is added into a halide ion, into a salt which has a halide ion. Now you can see it gives white PPT. This white PPT is for chloride. Chloride ion is there. Here you can see this is a slightly off-white or creamy precipitate. You can see this is for bromide. And this yellow color is for iodide ion. If yellow PPT forms by adding silver nitrate, it means this is iodide ion is present. For bromide, off-white or creamy precipitate, and chloride, it's white precipitate form. This is a color change in the halide ion upon addition of silver nitrate. Flames test. These are the metals. They're the part of your syllabus. Number one is lithium, sodium, potassium, and copper. Actually, these metals are not directly heated. Their salts are heated on the flame. So we call them flame tests. For example, lithium chloride or lithium nitrate, any salt of lithium will take and heat up in the direct flame. Actually, lithium burns with the red flame. Lithium burns with the red flame, and product is going to be lithium oxide, Li2O, which is in white in color. All these group 1 metals and group 2 metals, their compounds are white solid, and sodium burns with the yellow flame. And again, their product is sodium oxide, Na2O, and again, this is white solid. And potassium burns with the lilac flame. This burns with lilac flame, and product is potassium oxide, K2O. Again, it's white solid. And copper burns with oxygen. In the presence of oxygen, this produce green blue flame. Copper produces green blue flame, and product is going to be copper oxide. And again, this is copper oxide. Copper oxide color of this, because it's a transition metal, it absorbs humidity from the surrounding. So these are the flame tests you can see. This is lithium with the red flame, and sodium with the yellow flame, and potassium with the lilac flame, and this is for copper. These are the flames tests, different flame tests.